Okay, good morning everyone. My name is Carlo Bonamico, and today I will discuss issues and opportunities in HTML5 security. I'm working at a software consultancy called NIS, mainly in Italy, but also here in our London office. And I specialize in HTML5 and Angular applications and web application security and continuous integration and delivery. So, when I first gave my web application security training several years ago, many problems were not known to developers. So I got a lot of questions on basic things like SQL injection and cross-site scripting. Now, after a few years, things have changed. Several players have worked a lot in this field, especially the OWASP project, to share awareness and raise the knowledge in developers on how to prevent security issues. But however, we are in 2015. We knew that there should be flying cars and shiny new technology, but what we actually get is an increasing amount of security vulnerability. Those are charts from the CWE website, which show that things were improving for a while, but now the amount of new vulnerability discovered every year is still increasing. The reasons are many. Basically, the increasing amount of software which is being developed, but also the increase of the complexity of the software that we develop. And HTML5 is a key issue in this field because on one hand, has the big advantages of allowing web application to compete with desktop application. And now, in many fields, the web is the new default. You first do a web application, and then maybe you do a desktop application. And we have seen a huge increase in the development of single-page application. Well, the term single-page application is a bit vague, but what we mean is an application where a significant part of the interaction logic is on the client, where the server doesn't produce HTML, it just serves static HTML, it exposes REST endpoints, and it is the client which acquires data from those REST endpoints and dynamically display the results. So those are more powerful than traditional request-response web applications, but are they also more secure? And that's our question. We basically have two problems here. The first one, you know the quote, with great power comes great responsibility. If we discuss security, the more power you have, the more holes and risk normally you have, because there are more opportunities for attack, and if an attack is successful, more opportunities for damage. Also, it's true that many attacks on HTML5 application only handle the browser. They cannot attack the server. But now, within the browser, in HTML5, we have a full development platform with access to user data, to access to APIs, which in turn gives you a lot of critical and sensitive information about the user. Just have a look at the Xenotics website, which is a website for a tool for performing JavaScript vulnerability assessment and penetration tests to get an idea of how dangerous it is to inject a script in a user browser. The second problem is that the web is going on a big architectural change. We were used to application where the logic was on the back end, but also the generation of the user interface was on the back end, and the browser was basically stupid. It will just render forms, collect the inputs, and post back the results. Now things have changed, and the new single-page applications are based on a model where the business logic is still on the server, but all the dynamic view generation, interaction with the user, is moved to the client. And this changes many security assumptions, and the security model that we want to develop must change because the same rules that applied in the old case don't apply in the new case. On the good side, however, this new architecture has a single big advantage. The the fact that it forces, at least in the same degree, developer to separate business logic on the server from user interface on the client and have a well-defined contract in terms of the web service REST API or WebSocket API to separate them. And this is very important because in our experience of consulting with many companies about security, performance, and quality issue, the single biggest cause of problems, of performance problems, of maintainability problems, of security problems is the mixing and coupling of user interface and business logic. So separating user interfaces, business logic is a good thing. So if we understand this new paradigm and we follow the secure coding principle, we can see some here, and I will provide a link to the OWASP documentation at the end of the talk, we can achieve a greater degree of security in HTML5 applications. Going back to the risks, this is the traditional top 10 web application security risks that we all know from the OWASP website. And what we discuss now in this talk is what's different for an HTML5 application, what's riskier and what's better with respect to those risks. The one that we see in orange are just similar risks, but the solution is obviously different in an HTML5 application. Those in red are more dangerous in an HTML5 application, and we will discuss them more in detail. The green one are those that are simplified by the new architecture because there are aspects that can make those things don't happen or make them less dangerous. The pink one, using components with known vulnerability, is a special case because it's something that is becoming more and more relevant both in traditional applications and in single-page applications. We can start from cross-site scripting. Basically, cross-site scripting means that an attacker can send some input to your application through the URL, to a field, to some web service or database. This input contains some JavaScript code, which is displayed in the page of the user, mixed with the real application code. So it's basically a code injection attack. There are several ways of doing this, stored, putting into the DB, reflected through the URL, or DOM-based by changing the JavaScript logic that manipulates the DOM. And obviously, in a single-page application, especially with framework like Ember or React, this last one is the most dangerous because there is a lot more JavaScript logic, a lot more of manipulation of the DOM on the client, so the risk for DOM-based attacks is higher. The solution is clear. Just avoid external text input in the system to be treated as JavaScript code. So separate our application JavaScript code from user inputs. It looks very easy. What's the problem? The problem is that the HTML specification is very complex, and it allows for mixing together in the same lines of code many different languages. Each of them has different rules for how this is to be done. So you can have JavaScript within a CSS, and CSS within an HTML, which is within a frame within another HTML page. So properly applying all the rules for keeping JavaScript separated from text is very difficult in this complex scenario. The solution is escaping, so applying some transformation that tell the browser that this text must not be interpreted as JavaScript to be executed. In a single-page application, if you do a proper design, the logic and the data is very well separated from the user interface. And so your framework uses a templating engine, like templating expression in Angular or underscore in Ember, and it has a single place where escaping can happen. And this is a good thing. And in fact, for instance, in AngularJS, since version 1.3, all the binding expressions are already escaped by default. If there are cases where you want to dynamically insert HTML, like a rich text editor, or including some HTML from an external website, there are services and directives to properly do this in the safe way. There are also some tools that you can use to validate your application code, to perform some static analysis and to identify where potential cross-site scripting issue can arise, and I give you some references. The important thing to remember for what concerns cross-site scripting is that it is not a huge attack per se, but it is an enabler for other attacks. And in general, when we talk about application security, the risk of a small vulnerability is not by itself. It's the fact that it can be combined with many other vulnerabilities. Each of them is small, but the overall effect is very dangerous. A bit like when you mix Pepsi and Mentos and the things explode. Also, if we move a lot of user information to the client, so the data returned from REST services and the logic, it becomes more exposed to an attacker trying to steal sensitive data from your user browser. This is especially relevant for cookies because your session ID or authentication token gets sent as a cookie to the browser, and JavaScript code in the page can access it. So you must prevent interception and stealing of cookies and tokens, and this can be used with several attributes that you need to put onto your cookies. Also, you must avoid storing sensitive data, like password, credit card numbers, confidential information, in the various storage areas of the browser, like session storage, local storage, without encryption. And if possible, you should avoid storing them at all. The configuration of security parameters is also relevant, as usual. The first point is that if there is even a single man-in-the-middle operation between the server and the user browser, the interceptor can inject JavaScript code in the user page and basically do anything. So you should avoid man-in-the-middle attack at any cost, and this basically means use SSL everywhere. Now the performance cost of using SSL is almost negligible, so you should definitely use SSL for everything. There are also other things to pay attention for, like be careful with cross-origin resource sharing, so allowing other domains to access your REST services, unless you have a very strong authentication and authorization mechanism in place. You can also ask the browser for help. Modern browsers, like recent Chrome, Firefox, and Internet Explorer, have a mechanism which is called content security policy, where they can check whether the JavaScript code in the browser is safe or not. But for compatibility reasons, this is not enabled by default, so you should write some headers in your responses so that the browser understands that you want to turn on this mechanism. There are several libraries to do this. You don't have to do this in your application code for Node, for Java, for .NET, and so on. And several tools such as OWASP or the online security headers website to check that your website actually puts the right security headers when providing responses to users. For what concerns authentication, we have other aspects to consider. Traditionally, the authentication in a request-response application is performed by creating a post. You send your credential, username and password to the server. Server generates a session. The session is stored on the server somewhere, and an ID for this session is sent back to the client. All the following requests include the session ID, so when a request arrives on the server can check that for this session ID there is an authenticated user. Okay, this is very simple and has been working for 10 years and more. This has several issues. The first one is that it's very difficult to do clustering or single sign-on because the sessions are stored on the server. If you have multiple servers, you must share somehow the session information. And also, you have problems, security problems related to the use of cookies, because very often cookies are sent automatically to the server, and even in cases where you don't want them to be sent. If you reference in an email an image on someone's website, the person opening that image will send the cookie for that domain to the server, and that's the reason why webmail clients normally don't allow displaying external images. So, session cookie authentication is easy to implement, but it has security problems. It is not suited to the stateless nature of REST services. If you're writing REST service, the good thing is that they're stateless, so it's very easy to scale by just creating additional servers in the farm. So we must understand, and it's an important thing, that authentication and session management are two different things. I can have requests which are non-authenticated and not session-based, so like navigating Wikipedia. I can have requests which have a session, but are not authenticated. Many e-commerce websites, such as Amazon, use cookie to track your progress into the application, but you are not authenticated. We can have the traditional authentication with session management, and we can have REST stateless authentication. So we must now understand how to properly do stateless authentication. Normally, the idea is to use a token, not a session ID, a token which is generated when you log in, which is sent with every request, and which is validated by the server to check whether you are authenticated or not. And you see that there is no session on the server. The key point is obviously, how can I validate the token? And given a token, how do you know who is the current user? How expensive it is to validate the token? Can you share a token across many services? So you have an application which is, let's say, a mashup, which accesses many REST services from different servers. And so you need to send the same token to multiple servers. What's the solution? Recently, there is a new standard which has emerged, which is called JSON Web Tokens, pronounced JOT. And this is a very interesting standard, which is getting a lot of adoption because of a very simple idea. Instead of validating the token in the traditional way, where you must keep a list of the valid tokens, and this basically, again, means having some state on the server with the list of valid tokens, the tokens are validated with a cryptographic protocol. Basically, a token is composed of a random identifier, some claims, which is some information that you put in the token, like the username or the domain or the expire time, and then a signature. This signature is done with the private key of the server that creates the login. But then, the same server and also other servers can validate that the token is correct by just using the public key, as in digital signature and public key cryptography. So you can create this token and just validate everywhere that the token is correct without having to keep a list of valid tokens. And when you validate that the signature is correct, you don't just know that the token is valid, you also know what are the username, some custom data that you can put in there, and also the expire time of the token. There are many libraries to do that automatically. For instance, for Angular, there is this very good AngularJS library, which basically does all the token handling automatically for you. You just configure a few hooks and it's done. And there are server-side libraries to generate and validate tokens for all the major development platforms on the server side. A final question about token-based authentication is, where can we store the tokens and how can we send them to the client? We can store the token in the browser, in memory, in a JavaScript variable, or in the session storage. This has the advantage that in some cases where you want to have a very strong security, it only works in the current tab. You cannot open multiple windows. Also, as soon as you close the window, the variable is destroyed, and you cannot access the session anymore. You can, on the contrary, put the token in a local storage if you want to have access across multiple tabs, or even to have a remember me where you can close the browser, open the browser the following hour, and still have the session working. And it's up to you to choose. The important thing is that we should consider whether to send the token in a cookie or in a header. Sending it in the cookie is very easy to do, it's automatic, but it has all the disadvantages of cookies that we mentioned before, that they're not shared across domains, that they get sent in cases where you don't want them to be sent. On the contrary, using a custom authentication header does require some additional coding effort, but guarantees that you send the token only when you want. So only when you're calling REST services, only when you call specific function of the application, and you have much more control. Also, a final advantage of using header is that it makes almost impossible to have a cross-site request forgery attack, which is a very dangerous attack and much more widespread than we think. Another problem, and this is maybe the biggest difference between a traditional application and an HTML5 rich client application, is how you do authorization and access control. Typically, in a server-side application, you check the permission or the role of the user on the server side. So within a JSP page, PHP page, within a servlet, within a controller, and you can do this in every part of the application, and you can use also this information to filter what information is displayed to the user. I can load an entire object from the database, and according to the roles of the user, just choose to display some fields and hide or remove from the page other fields. In a single page application, will this code in Angular or in a similar framework will be secure? I have a button. I say that if the user is not an administrator, I remove the button from the page. Is that secure? No. Okay. Why? Because the user can just press F12, open the developer tools, and just manipulate the DOM directly and re-enable the button, or even possibly just call the REST service directly without going to the page. So basically, while traditionally in a request-response application, the door that checks access is attached to the room. In an HTML5 application, if we do what we've seen here, it's basically like saying, I take this door, I move it outside 10 meters from the room, and I pretend it to be secure. Obviously, it isn't, because people will just get in without going to the door. So, if you must remember just one thing from my talk of today, remember this. In an HTML application, security is still a responsibility for the server. So access control, authorization still must be performed on the server. Okay? So every time the browser sends a request for a REST service, the server must check that this request comes from an authenticated user, which has a valid token, and that this user has the right permission to perform this operation. Okay? Also, remember that the same rules apply for input validation. So making a validation on the type of a data on a form on the client side is practical for the user, but it's not secure because the attacker can send dirty data directly to the REST service. On the contrary, what's up to the client is usability. If I perform the authorization check on the server side, when the user clicks on a button and it's not authorized to click on this button, the user will click, a request will be made to the server will deny the request, get back to the client, and I would see a message, you cannot press this button. This is not very usable. The user expects that if I cannot press a button, the button is hidden or it is disabled. So this part, which is for usability, not for security, is up to the client. So to properly do this, you need to set up a REST service which sends the permission for the current user to the client, so that the client can use this information to automatically enable, disable, show, and hide the various parts of the application. And this, for instance, with Angular can be done with a directive like has permission, delete post. So if you have the permission to delete a blog post, then the button is enabled. When you want to check authorization information, in many frameworks, you just check based on the group to which the user belongs. This is an approach which works, but it's not ideal, because it can happen that the access rule change often, and it's also difficult to validate that you have implemented the access rule correctly, because the access rules are spread all over the application code. So what we suggest is to use role-based access control. So to basically separate the definition of a group, of a role, from the permission that this group has. So in the source code, instead of checking if the user is an administrator, we check if the user has a permission. At this point, this line of code, the first line of code over there, will never change, because the permission is, can you delete this information? And it is also much easier to test, also with automatic tests. I can write an automated test. We say, okay, set the permission for the current user to an empty list, try to do this, it should fail. Okay? So you can check security requirements with an automated test, which is a very good thing. Then you define a group of a role as a list of all the permission that this group has, and then there is an authorization system which maps a user to a group to a list of permission, and then computes at login what is the list of permission for this active user. So we have a permission check which is focused, very readable, easy to implement, easy to test, and doesn't change if your security requirements change. On the contrary, you have a centralized role definition, which is easy to review, to check that also with the customer, that the mapping between groups and roles and actual permission is the one that the customer wants. And it's easier to change because it is centralized. Finally, we discussed the usage of third-party components. That's a big problem, much bigger than everyone thinks now. Because when we develop application, it's very productive. We can do magical things with a few lines of code. But this basically means that the code that we write is normally, I don't know, 5–10% of the actual code that runs within an application. Because the remaining huge amount of code is below the surface, is within third-party libraries, components, and packages that we are using. So the security of our application depends, obviously, significantly on our application code. But in many cases, even more on what we trust as third-party components. This is not the final solution, but you should review security information for your components that you use. You should subscribe to the security announcement lists for the libraries that you use. And you can also use some tools, specifically retire.js for the JavaScript part, and tools like OWASP dependency check or Sonatype tools for checking the dependencies in the Java world or on the server-side world. Those are tools which perform a scan of your source code, identify all the dependencies, and then produce a report by cross-checking this list of dependencies. Like, let's say that your application uses jQuery 161. Then they go to the NVD database, to the CWE database, which are vulnerability databases, and they match this information and they produce a report saying, okay, your application is using those libraries have those known vulnerabilities. Okay. At this point, obviously, it is not guaranteed that your application has this vulnerability, because maybe it is in a part of a library that you don't use. But after looking at this report, you can check and identify potential critical problems. A final word. When we discuss security, in many projects, the main problem is that of budget, time, and we could call it feature pressure. So the fact that the customer and your team leader and your company always ask you for more functionality. Well, we will think about security later on. So is it true that security is an overhead, that it is some weight that drags down a project without bringing value? I think not. I think that in reality, if you know security basics, if you are trained in the principle of web application security, adding security doesn't really mean doing much more work. It just means doing work in the right way. In most cases, also, adding security just means following standard good design practices, so good software engineering practices, keeping software modular, separating concerns, favoring clarity, readability. Maybe another big source of security bugs is writing complex and readable code, which then is difficult to debug and is a good source of security problems. Also favor composition, to split your code in many individual components that are easier to test to ensure that they have less quality problem and also less security problems. Also, a new field which is becoming more and more interesting, it is related to the BDD test approach, so doing behavior-driven tests where you create an executable specification and then you test the behavior of your components and of your application with a text-based description, is that of also writing tests that validate security assumptions, like authorization assumptions or data protection assumption. So you call a component and check that in the response you don't get some sensitive information, or you call a component with a given profile and you check in your test that you can or cannot access this information. So in general, the forces that helps you writing more secure code are in many cases the same forces, the same principles that allow you to write more robust code, more clean code. So if you follow good software design principle, you get both benefits at the same time. Also in general, if you write code which is modular, which is tested, which separates concerns, this responds much better to changes. And if your software responds better to changes, it becomes easier to adapt to changing, evolving security requirements and also to changing, evolving feature requirements. So you have an alignment between the two needs. I provide you with some references about additional information on those topics, particularly the OWASP guides on secure design principles and the testing guide, which has a list of security problems, how to prevent them, and how to check that your code doesn't have them. More references about specific security issues in HTML5. Here is a very wide field. I definitely recommend the second and the third link about the OWASP guidelines for HTML5 application and a discussion of framework security on SlideShare. Thank you for your attention. If you are interested in these topics, you can attend our security development training courses. I have a few leaflets here if someone is interested. Or you can contact us for architecture reviews, code reviews, or supporting and mentoring your teams. You can find more presentation about AngularJS and security on my SlideShare account, or follow me on Twitter. So thanks, and if there are any questions, I'm ready to answer. Did anyone use the website to ask questions? No, okay, so we just go the traditional way, and please do ask any question if you want. Thanks. Mm-hmm. The main recommendation is not store the encryption key on the client. So basically, if you have to store sensitive data on the client, you should encrypt it with some key derived from data that the user enters just at the moment and then is not stored anywhere else. But if you can, just avoid it. The other question? Sure. Well, there are three main approaches that you can use. You can use source code analysis. There are several tools for JavaScript on the client side and for Java or .NET on the server side. Like for Java, well-known one are Find Security Bugs. I will post some link on Twitter after the talk if you are interested. There are also commercial products such as Coverity that you can find here at the conference. Or also on the client side, this is a more recent field. The most known one are JS Prime and Scan.js that I mentioned in the talk. We still have some problems in the fact that those tools give you some, especially on JavaScript, the rate of false positive is still quite high. So they will give you a list of potential injection problems, but you still have to review them manually and to check what are real and what are not. The server-side tools are more mature in this sense. Another thing that you can do is to perform, obviously, security reviews manually. The third type of tools are dynamic scanners, and here the most promising approach is that of proxy-based tools. So, for instance, OWASP Zap, such as also other tools like Burp and other commercial products, work in this way. They set up a proxy. You navigate your website through this proxy so that the tool records all the action that you do. At this point, the tool has a good idea of not only what are the pages in your application, but also of what are the requests that you are sending to this application, what are the parameters to those requests, what are the cookies that you're sending. And then starting from that, they will start sending dirty data in the parameters. Start changing and putting injection targets, fuzzy data, wrong data into those fields, and see whether the response changes. So you send the original data that the user wrote, you send a wrong data, and you compare. If the result is different, then maybe the attack was successful. OWASP Zap. I can show you this project. I will post the link on Twitter after the talk. This is an important concept because if you also do functional tests, so you have a functional test suite, you can launch the functional test suite. The test suite will go through the scanner, and so while you're doing functional testing, it will also do security testing. And Zap is a project which is open source, but is getting very much mature. It's composable, it has plugins for many tools. We regularly use it in our vulnerability assessments, and we find it quite effective. Okay. You can. Basically, you configure Selenium to go through Zap proxy. So you launch Zap, you launch Selenium. Selenium navigates your website through Zap, and Zap records all the interaction. When the functional test has finished, then you tell Zap, OK, replay the same session, the same navigation that the functional test did, but try to attack the website. So the first time you perform the proper navigation, the proper functional testing, the following time, Zap will try to repeat the same request by changing the content, introducing more attack vectors, and try to break the system and produce a report in the end. So it can be integrated also with a continuous integration server like Jenkins or Taft4 Go. Okay. Any other question?
Are there any typical places in the Angular applications where you might miss escaping?
The most significant one is when you need to display HTML coming from user input. Let's say that you use components for rich text editing, like for editing a blog post where you can format, introduce links, and so on. So in these cases, it's better that if you try to put this HTML in a page directly, Angular will not let you. Then you must explicitly call a special directive which says this content is not safe, so please introduce additional checks. The main point, and I had a slide about this, is to use those two services, SCE provider and sanitize provider, where you can configure what are the HTML tags that you allow, what are the HTML tags that you deny, and configure in a fine way how this happens. If you need to display HTML dynamically in your Angular application, you definitely need to read this document about security. It's quite short, it's 3-4 pages, but you definitely need to read it. Okay. Any other? Good. Thank you, everyone. I am anyway available here and then immediately outside afterwards for other questions or discussion. Thanks to everyone.